Okay, so we've kept the original first order approximation in for e to the x. And that's what we have on the screen. And then we have our second one that we just derived. Instead of x over 2, we've got x over 3 in this one. So if we change it to h of x, what do you notice?
So it's the same general shape of the function, but it's squished more, I guess. This doesn't go down as far.
Yeah, it didn't change nearly as much as I was expecting it to, actually. Wonder how could we tell if they're different?
I mean, I hope they wouldn't change that much because you're still trying to preserve the derivative.
Yeah, that's a very good point. Near x equals 0, they ought to be somewhat similar because we've defined them that way. So maybe we can plot, to look at the difference, maybe we can plot g of x minus h of x for x just being negative is the only time they're going to be different. So from, like, say, minus 3 to 0. There we go. So we actually do see.
It gets more different as you go further and further.
Yeah, the subtraction is negative, so that means h of x is larger. But anyway, okay, so that's different. But let's look at a different function. What would you like to pick? Oops, sorry about that.
Let's do sin x again.
Okay, sin x. All right, so there's here's sin x, and maybe zooming out was a good idea. What do we do? Minus 20 to 20.
Yeah.
Okay, so there's what his approximation looked like, and then the one using x over 3.
It is a different function.
It is a different function. Yeah, this one is easy to see that it's different. Wild. Okay, so but if I went just from, like, minus 2 to 2, maybe it has the same property.
It looks almost identical.
Yeah, actually, can you even spot the difference? Okay, here's
this is h right
that's
now.
h.
So,
and there's g. What are some things that you can see are different?
I think g, this wave is a bit narrower, and maybe it doesn't go down as far as h did, but I'm not entirely sure.
Alright, so it looks like it goes down to minus 0.6.
I guess it's about the same. But this wave seems to be a bit wider.
Yeah, it's interesting. Huh, wild. So this is neat. This is, So what do you think about calling these reflections?
I mean, for the purposes of derivatives, I guess around 0, they could be considered reflections, but I don't, if I see just this, I don't think sin x.
Right, yeah, for sure.
And if I see sin x, I don't think whatever this is.
Yeah. It's interesting how first of all, it's interesting how different it is. If you just say, all I want to do is preserve the derivative here, you can see that that's not enough information to preserve the function, number one. And then actually we can see here different choices of how to preserve the derivative lead to very different functions, which is pretty cool.
Yeah.
That's neat. It's a great calculus review, great little linear algebra review. It's fun. Good job this morning.